Okay, today's May 26, 2011, textbook is technically page 430, and we're doing lesson 7.6, Blue Notebook, page 363. I'm just gonna briefly give you an overview of 7.5, and then we're gonna move into 7.6. So 7.5 is just the introduction of exponential functions on a graph. So that sounds like a lot. The idea to this is you guys need to recognize what an exponential function is. So remember, we have our f of x. B is going to stand for our base, and our x will be our exponent. Okay? Whoa. How is that like that? Okay? So what we've covered now that we've gotten to this, is if you guys remember, we also had quadratic function. Okay? And we also dealt with linear, mx plus b. You guys remember those? So we have three different types of functions now. This is a linear, quadratic, and we're dealing with exponential. A linear function, if you guys remember, is any form of straight line, can face any way it likes. These are all linear functions. You guys okay with that? Okay, what I'm going to do is give you an example of a specific linear function. That linear function is written as f(x) just equals x, okay? And in that linear function, what happens is when we draw, we go over 1, up 1, over 1, up 1. So the whole idea is whatever x is equal to, y is equal to. So if x is 1, y is 1. X is 2, y is 2. X is 3, y is 3. That's a linear function. You guys, we did that in grade 9 and grade 10. Okay, the next thing we're going to be dealing with is we've gone about quadratic functions. Okay? So you guys remember they're the U-shaped objects, look like this. Can be drawn anywhere on the graph. These are all quadratic functions. I'm going to specifically draw the one that we're used to, our base model, where our origin is here. We go over 1, up 1, over 2, up 4. Hopefully this is not new to any of you. Over 3, up 9. Okay? Not the most best perfectly drawn quadratic function, but that is our quadratic function. That is f at x is equal to x squared. So we have f at x is equal to x, f at x is equal to x squared, and what we're dealing with today is we're drawing an exponential function. An exponential function is also known as an asymptote. Okay? So I want you guys to write this down. You're going to have to get the definition of this word as soon as I figure out how to spell it. There it is. The function we're going to draw right now is f at x is equal to b at x. Okay? And actually, you know what? We'll do specifically. We'll do 2. Okay? The way this function works is it is going to go over 1, and then the amount it goes up by is constantly multiplied by the number 2, whatever our base is. Okay? So, for instance, when x is 0, oh, I'm writing the wrong thing. Two to the power of 0. So when x is 0, what is y equal to? 1. 2 to the power of 0 is 1. So when x is 0, I'll do this one in red actually. Our y is 1. What about f at x? When x is 1, what is y equal to? 2. So we've gone from 1, now we're at 2. What about when x is 2? So if you guys notice, I continuously replacing the exponent with these numbers. 4. So when x is 2, we're at 4. 1, 2, 3, 4. And we'll continue this one more just to get a feel for it. When x is 3, there you go, good. Morning, Jordan. Really did. Finished it. Okay, so the idea of this function from here is that it's going to continuously get steeper and steeper. If you guys notice, I went over 1, up 1. Then I went over 1, up 2. So I take the previous amount and multiplied it by the base. I went over 1 again. This time I went up 4. So I take the amount I previously went up by and constantly multiply it by 2 again. On the next one we go up by 4. We multiply by 2. The whole idea of this is we have an exponential function. And what you're going to notice with an exponential function is it'll never cross the x-axis. It'll continuously get closer and closer and closer and closer, but it's never going to cross it. So that's the difference between a quadratic, a linear, and an exponential. Exponential is going to continuously take off, get higher and higher and higher. Okay, so we have 2 different examples of b here. B is our base. So if you guys notice, the base in the red example is between 0 and 1. So what happens on that graph is on the left side of the y-axis, it's actually coming downwards. So say we're always heading to the right. It has a very high point and it heads downwards, cuts across, never touches the x-axis, and continues lower than 1. When b is greater than 1, on the left side of the y-axis, it's below 1. It hits 1 at the y-axis, and then it takes off. Increases exponentially is the idea. What's important is both of these, if you'll notice, they cross the y-axis at the value of 1. That's when x is 0. Why is that? Does anyone know? If I have 5 to the power of 0, what does it equal? 10 to the power of 0. What about 1/4 to the power of 0? Still equals 1. So no matter what base I have, it's going to cross the y-axis at the number 1. When x is 0, we know y will be equal to 1. Doesn't matter what the base is. So all of these exponential functions are going to be crossing this graph at the base of 1. Now, we figured out how to head upwards. Actually, let's draw another one of this. Okay, we're going to specifically work on graphing f at x equals the base 2 to the power of x. In other words, x can be any number. We're going to graph what it would be on a graph. So one way to go about this is I'm actually going to start at, let's say, -10 on my x, and I'm going to find my y values. So when x is -10, I'm going to plug that in. We'll do it on the side. F at x is equal to 2 to the power of -10. Now, we just did this on the quiz. How do I make -10 a positive number, Ian? Flip it. So this is actually equal to 1 over 2 to the power of 10. 2 to the power of 10 is a pretty small number here. Let's figure it out quickly. Okay, so like we said before, we're trying to solve 2 to the power of 10. So 2 to the power of 10 equals 1,024. So they give me a fraction, but I need to give this an actual y value. So which means I still have to divide if I'm to graph this on the x and y axis there. I need to actually find what 1 divided by that is. So I'm going to take 1 divided by my answer from before equals, because it's e to the -4, what they're saying is it is 0.12 0.034. So our value is 0.0009. You guys notice it's very close to 0, but it isn't exactly 0. So we're going to get very close to the x-axis. Now, instead of going 10, I'm going to write this as a fraction. It was 1 over 124. I'm going to jump to 6. Exact same question. This time our exponent is 6. So, f at x is equal to 2 to the power of negative 6. Just like Ian said before, I need to flip this into a fraction, put it to the power of 6. Let's solve. 2 to the power of 6 equals 64. So this is now a fraction that says 1 over 64. But again, that's just a fraction to me. I want to measure it on the y-axis, so I'm going to divide that. 1 divided by 64 equals. This one's larger than the last number, but still much smaller than 1, 0.0156. If we look at the scale on my graph, it's still pretty hard to graph that. So I know I'm still below half of 1, so I'm going to stay down there. I'm going to jump ahead again to negative 2. Now, the reason we did it this way is because I wanted to relate the fractions to what we were just doing in exponents. Matthew brought up a good point. Another way we could have solved this, 2 to the power of, if I just write in negative 10, it'll give me that number. Exact same number we had before. Same idea with 2 to the power of negative 6. It gives me the decimal. If I'm asking for the answer in fraction form, though, we need to know how to do this the way we've done it before. But in terms of graphing, we can just plug that number straight in. So using that method, let's do the next one. 2 to the power of negative 2, 0.25, which is what? Anyone know? 1 over 4 is a fraction. 0.25, we're going to say we're up here. Finally, when I get to x at 0, what do we know the answer is going to be? We know it's going to be 1. F at x is equal to 2 to the power of 0. Any exponent of 0 is 1. So on the y-axis, we're at 1 now. This is where the graph is going to start to take off. So if you guys notice the start, this is what we meant by an asymptote. This graph or this line is never going to touch the x-axis, but it's very, very close to it. That's because of my very poor dexterity. Wow, that was terrible. Let's try that again. Fine movement in your hand. Yeah, getting better. Okay, so the graph's coming across. It's finally starting to increase at 0. Let's look at when x is 1. So when x is 1, we have f at x is equal to 2 to the power of 1. What's that going to equal? Real simple. I'm going to be at 2. Okay, again, I'm going to jump ahead. What about at 4? F at x equals 2 to the power of 4. Anyone know? It's a question on your test? Good. 16. Already, if you guys notice, when I'm at 4, I'm not even on this graph. So I'm going to scale back a little. 4 wasn't even on the graph. Let's try 2. Sure, let's do 2 and 3. How are we doing for time? Ooh. Okay, so instead of going to 4, we noticed for this graph it was too high of a jump. So we went back and did x to the power of 2, n to the power of 3. X to the power of 2 was 4. X to the power of 3 was 8. I plotted those 2 points, and if we look at this graph now, it changes direction exponentially. All of a sudden, it is taking off after the y-axis. Okay, so technically that was less than 7.5. I thought I was going to be able to go through it faster, but we'll take our time. So that was 7.5. I'm going to give you your homework right now. Your homework is lesson 7.5, text page 423. Numbers 1 to 4. It's a very, very straightforward homework. Please try it. If you need to know it for tomorrow.